been working quite a lot in everything connected to outreach in the Wikimedia movement. So I've been creating collaborations with educational, cultural, and governmental institutions. I care very much about the gender gap in Wikipedia and other sister projects, and I've worked quite a lot to make it smaller. Lastly, I've been focusing on Wikidata, which, as you can see, is also my PhD topic at the School of Education. So I'm currently doing my research about it. And as a lecturer, I've been experimenting with it in the classroom. So I'm hoping that today I can share some insights from all of these work that I've been doing. And yeah, let's delve in. So the menu that I prepared for you today has 3 courses. The main course, or the appetizer, is some background on why Wikidata was started in the first place. And the main course, of course, would be how we use Wikidata, different uses and different tools that we have. And I hope that that's the main thing that's going to inspire you to learn more about Wikidata. And lastly, I'm going to talk about some conclusions and a glimpse to the future. So right before we begin, I would be very happy, first of all, if you can, those who are connected, if you can open your cameras, that would be amazing, because I would like to see you as well. And I was just curious, so I can get to know you a bit better, is how many of you have used Wikipedia in the past week? You can just raise your hands. I'll wait. Awesome. I saw at least one. And how many of you have contributed to Wikipedia? Oh, there's a bunch of you. Awesome. Good. How many of you have contributed to Wikipedia in the past week? Not just read it, but actually edit it. A fewer hands. Oh, there's a few of you as well. Awesome. Have any of you used it in research or in the classroom? A few. Awesome. Now, the same questions for Wikidata. So how many of you have used Wikidata in the past week? Just so I can see what we're dealing with. Raise your hands high so I can see you in the classroom there. Okay. How many of you have contributed, added something to Wikipedia in the past week? Awesome. And have any of you used it in the classroom or in research? No one. Oh, some of you. Okay, awesome. Okay, I hope this is going to be, we have a mixed class, so this is quite great. Some of you already know Wikidata and contribute to it, and some of you are not. So I'm hoping that this presentation is going to be showcasing some new things to all of you. And let's begin part 1, background. So in order to speak about Wikidata, I wanted to take a step back and say something about the world that we live in today. And I think today it's very difficult to progress or to move anywhere in the digital world without hearing buzzwords like Wikidata, artificial intelligence, right? Data science. These are part of the conversations and, you know, have been in the past, I would say, decade, but more and more so as we progress. But there is no big data or data science without data. And this is why Wikidata is so important and such an important part of this ecosystem. But in order to understand exactly why, we need to get to know what Wikidata is and where did it come from, basically. So I want to give you some background. Now, I'm curious, how many of you know the man in that picture? Second, because I know we are being translated. And so if anyone knows who this is, oh, Nanu, tell us, you can unmute.
Yes, hello. Is the guy who did the www?
You are absolutely right. And this is Tim Berners-Lee, the man who basically invented the World Wide Web, not to be mixed with inventing the internet. I love this picture, right? So this is on the left is Tim Berners-Lee, who invented the World Wide Web as we know it. And on the right, it's Vinton Cerf, who basically invented the internet. And these two need to not be confused. The web is basically an application on top of the internet, okay? And Tim Berners-Lee is a man that I think we owe a lot to, because he's a man of a vision. And, you know, besides creating the World Wide Web, which is basically the internet as we know it today, Tim Berners-Lee had a vision. So back in 94, for the first time, he starts to speak about something that he calls the semantic web. Now, in order to understand the semantic web, I want to take a step back and describe the internet in general and some of the different evolutions that the web had. So when the internet just started out, it was the late 90s and the beginning of the, sometimes in the early 90s, the web looked, it was the first version of the web, what we call Web 1.0. And in this web, only, you know, very big companies had websites. And in these websites, they presented materials, and we as users could only read that information. That's it. We couldn't do anything else. Now, at the end of the 90s, at the beginning of the 20th century, the beginning of 2000, the web goes through a very important evolution, and this is what we call Web 2. And in this web, this is what you can see in the second part here of the slides. I hope you can see my cursor. In Web 2, something very important happened. We can suddenly see websites that allow users not only to consume information, but also to create it themselves. So instead of just reading passively, people can start sharing information online. And this is basically the internet as we know it until today, I would say, right? All the websites that we all use, like Facebook and Twitter and Instagram, and of course, Wikipedia and all its sister projects. And we have communities of users who share knowledge. Now, what Tim Berners-Lee starts imagining right back, so you can imagine that now, the beginning of the 2000, right? When we start to see Web 2 platforms, this is exactly when Tim Berners-Lee is already envisioning the next phase of the web. And he started to talk, he starts talking about the semantic web, as I said, back in 94, but it's really the early 2000 where he really where he writes a really important document called The Road to the Semantic Web, and really starts talking about it in conferences, etc. And what he describes is another evolution of the web. Now imagine that on top of the web as we know it today, all the websites that we all know and use, YouTube, Facebook, all of these, and Wikipedia, we have another layer. And that layer is the layer of data. Not just data, but structured and linked data. So we can actually query it and get answers. And the very interesting thing or difference is that this is not only for humans. This data would be accessible to both humans and machines. It's a very important thing. Now, this new evolution of the web is called Web 3. Sometimes it's called structured linked data. Sometimes it's called the semantic web. Sometimes it's called linked data. It doesn't matter. It's all almost the same. It's different people describing the same phenomenon in different ways with different, slightly different changes, but it doesn't change the fact that we see another step in the evolution of the web. So the idea is very simple. With a world in which we all live in, right? We have abundance of information, so much knowledge is out there, but we can't always access it really easy. So I'll talk about that in a second, but this is basically why we need structured linked data, because it's part of what helps us to make sense of the information around us and to access it really quickly and easily. So as I said, Tim Berners-Lee had a vision. And since he did that, since he had that vision and he describes it, the humanity has been trying to basically make that dream a reality. And humanity keeps failing, right? It keeps failing. And there are different experiments, different, I would say, different efforts around the world to create a semantic web, but none of them really succeeds, or they succeed in a very small scale until Wikidata is formed in 2012. It was the end of 2012. It was opened in a really small number of languages and then really formally launched at the beginning of 2013. Now I want some of you already know Wikidata, so I'll just say it's basically a database, right? It's a website that holds data, structured linked data. It's on a wiki, just like Wikipedia. Everyone can edit it. It is multilingual, right? Which is really important. And I'll be talking about that later on in the presentation. And both humans and machines can read it, which is really, really important. And of course, it's under a CC0 license and accessible to everyone. But I want to go back to, so now you know that Tim Berners-Lee had a dream, and humanity has been trying to basically fulfill that dream. They don't succeed until we have Wikidata. Now, I want to tell you that Wikidata today is basically the biggest semantic web platform that humanity ever created. It holds over 91 million items, over 25,000 users. Institutions donate their data into Wikidata, and it's a hub that connects different databases. And AI, artificial intelligence, is using it all the time. But I want to go back, again, finishing our introduction, and just tell you a bit about why it was created in the first place. So what prompted people, back then it was a group of people in Wikimedia Deutschland, among them Danny Vrendicic, and what prompted them to start Wikidata? So they simply wanted to answer a very simple question. And the question was, give me a list of all the women who are mayors of cities, right? Ranked according to the size of the city. That's what they wanted. They wanted a list of women mayors around the world ranked according to the size of the city. And if you think about that question, and let's say that you're like me, have been using Google, if you go to Google and put that question in, you will get, what kind of answers will we get? We will get, well, today we'll get a list, right? But back in the day, before we had Wikidata, we would simply get a list of thousands of websites that mentioned maybe the words mayor, women, size, city size, etc., etc. But what we will not get is a list, an actual list of women, mayors, right? So this question is what basically prompted the start of Wikidata. And I would also like to give a bit of a broader perspective, right? And I'll use Wikipedia, that you all know, to do that. So as you know, in Wikipedia, we have around 300 languages, right? And when something happens, let's say a celebrity dies, right? Or something drastic happens in the world, and we need to update that date of death. And then what will happen? We will simply have, before the days of Wikidata, we will simply have to update it almost in 300 languages manually, right? So that's a lot of volunteer work done. And it also created differences between different languages because, I don't know, let's say that you did some kind of, you want to know how many people live in some place, right? Let's say in Yerevan, okay? And let's say that you did a survey, and now you have an updated number of the population size in Yerevan. And it's probable that, you know, Armenian Wikipedians, being awesome as they are, will immediately know about that, and they will update the article in Armenian about the population size in Yerevan. But will it be updated automatically in all the other languages? Probably not. It will probably take longer to update it all in different places. So that means that for a single datum that needs to be updated, we need to do it repeatedly. And also it will create an imbalance between different Wikipedias, because probably it will not be updated exactly on the same time. So one Wikipedia version in one language, in Armenian, would be very much up to date, but maybe Hebrew Wikipedia will take a bit longer to get there, right? So that's one I would say challenge that we have in Wikipedia. Another thing that we have in Wikipedia, and that which is awesome, is, as you all know, categories. Now, categories are great. Let's say that we want to know all the Armenian writers that are on Armenian Wikipedia. Then we can go to the category, which I'm sure you have, and we will get a list. That list is awesome, but let's say that I want to make it a bit more complicated. And I now want to know all the Armenian women writers, and I want only women who were born between 1825 and, I don't know, 1920, because that's when my focus is, that's when my research is focused on. If I want that, categories will not be able to help me, right? Categories are great when they're focused on just one thing, but the moment that I want to try to complicate it a bit and get more accurate information about more specific things, categories are limited. And so, although they're awesome, they will not give me what I want. So that's another challenge that we have on Wikipedia. And the most frustrating thing is, this information somewhere floats in Wikipedia, right? We have it somewhere floating in Wikipedia, but we can't get it directly in a click of a button, right? Because the information is not structured in any way. So that's another challenge that we had. And the last challenge that we have has to do with GLAMs. I don't know, can you raise your hands if you've heard of GLAMs before? I'll let it be translated for a second. Only one. Okay, so GLAMS is basically acronym in our movement to galleries, libraries, archives, and museums. Or in short, it's an umbrella term for collaborations with all sorts of cultural institutions, which you have quite a lot of them in Armenia, as far as I know. And if you know something about museums or libraries or archives, then you know that each such institution has their own metadata about an item. So when you go to a museum and you look at a picture, the metadata would be who painted the picture, when, what is depicted in the picture, what is the provenance of the picture, et cetera, et cetera. So all different details about the pictures that you see, that is not the picture itself. Same goes for books or for any archival material. And humanity has always wanted, it was a kind of a dream for humanity to basically have a website that can show all the museums, like all the artifacts from all museums around the world, or to have a website that can show all the books from all the libraries in the world, et cetera, et cetera. But it was impossible to do. There have been efforts to do it, but they basically failed or succeeded only partially because it is very difficult. And the reason it's so difficult is that basically there is no one way of doing it. Every single institution has its own way of creating that database, that internal database, and each institution uses a different method of metadata for their items. So they would describe the items in different way. There is no international standard for it. And so when you try to bring together all of these different databases, they can't talk to each other. So that's another challenge that we had. So all of this is describing different, obstacles or challenges that we have before Wikidata that are basically being solved when we have a structure linked data database like Wikidata. The cool thing is about it is that it's the biggest semantic web platform that humanity ever created. It is multilingual, which is super important. It is built in such a way that for the first time it connects different databases around the world. So it becomes like a hub for metadata, and it helps us do the different types of other wiki work that we had to work really hard to do before, and we can query it. So, okay, this sounds quite interesting, but it's all very theoretical, right? So why don't we take a look at some examples? But before I do, I want to pause because this is the first appetizer, right? This is the introduction for us. And I just want to pause here and see if there are any questions about anything that I've said. Okay, I see no one moves. So at least the people in the classroom that I can see here. So Susanna, I trust you that if there are questions, you'll let me know. I'm just going to continue. And let's take a look at some examples of how Wikidata looks like and what we can do with it. So this part is the main course, right? And I will go through all sorts of examples from all over the world. And I will start with two basic, very, very basic queries, what the results are, and then I'll take a look at some case studies from around the world. And lastly, I'll show you some tools. So let's delve in. I'm going to out from my presentation just because I want to show it to you live. And this is a very simple query. Don't be alarmed if you have never seen it before. This is something that looks really, really intimidating at first, but I'm not a programmer and I studied it. It's really not that difficult. You can learn it quite easily, and I know that you have some really awesome Armenian Wikidatas in the community who can help you learn all of that. But this is a query. This is a query that's written in a language called Sparkle. This language is not specifically for Wikidata, but it's for everything that is semantic web. And basically what I've asked this query to do is to go to Wikidata and give me a list of all the women physicists that Wikidata has. And let's see, I'll run it. This is the big blue button here. I'll run it and let's see what we get, okay? So as I run it, Wikidata gives me back 1,933 results of women physicists. Now, wow, this is awesome in itself, right? I mean, before, if we would write women physicists in Google, we would not get a list like this, right? So this is amazing. This is the power of linked open data. I can ask the database questions and I can get specific answers. And here it's just a table, right? Now, we live in the 21st century and this is already 2020. So just a table is a bit boring. So in a click of a button, we can change the visualization and let's say see an image grid. So this would show me all these women, but it will show me the pictures of them, right? And in another click of a button, I can see this in a timeline, right? It will take a moment to upload, but I can see a timeline of all these women physicists. It's a bit heavy, so because there's almost 2,000 results, so I'll let it upload. And I want to pause here and again say, this is quite amazing, right? I don't know about you, but I grew up when the internet just started. So when I finished high school, the internet was just starting to develop, and we didn't have that stuff, right? We didn't have the ability to create a timeline in a click of a button. We just didn't. I remember myself sitting for hours in different libraries trying to figure out who's, let's say, who are the, I really love art. So let's say, who are all the musicians in a specific period, who came before whom, and how is it's connected to the different writers and to the different architects and to the different painters. So suddenly we can do all of that, and we can see all of that in a click of a button, which is quite amazing. Now this timeline allows me to explore all these women, and I can zoom in and zoom out. I won't now because I want to progress, but I want to show you one more visualization that comes with the very basic query service for Wikidata, and that is a map. So because I requested the data, this data, I can also put it the birth date of all of these women physicists. I can suddenly see it on a map. Now, how amazing is that? Because that actually changes the way we can interact with information. Before, when it was just a list of women, I couldn't see it visually, so I couldn't ask myself different questions, right? Like, could it be that there aren't women physicists in, I don't know, Uzbekistan? Maybe there are, but suddenly seeing all these women on a map allows me to ask different questions and to question what I see, right? To interact with this information in a new and exciting way. So all of this is simply happening because we have structure linked data. This is all part of the very basic query service of Wikidata. Now, I didn't mention it. You don't have to write anything. I will make sure to send my presentation to Susanna, so you can have it with all the examples later on. The presentation has all the query results, right? So I'm going to skip it, but this is how it looks like. And I want to move to the second example. If I remember correctly, some of you are medical students or have been medical students. So I want to show you another cool Wikidata query. It's running already. And this is showing us the different diseases and their symptoms, right? So this is like a bubble live thing. And you can see that, for instance, this disease can have different symptoms, and you can see that it connects to other things. Quite a different way to, I would say, to study medicine. Again, one that would not be possible without structure linked data. So I just wanted to show you this cool thing, because I know some of you may not have seen it. Okay, now that you saw two very basic, these are very, very basic queries, just to give you a taste of what it can do. Now I want to take you to a trip around the world, sort of, and give you examples from what's happening all over the world. What can we do really with Wikidata? And I hope this is this is going to be the most inspiring part, hopefully. So let's explore some of the main uses of Wikidata around the world. Again, I want to pause here to see if there are any questions before I continue. Okay, I'm continuing then. So the first example that I chose to show you is from the Metropolitan Museum of Art. This is one of the most famous museums in the world. It's in New York. If you haven't been there, I highly advise you to visit there someday. This is, you know, it's a good, I didn't say that at the beginning, but I know this is a very difficult time for all of you in Armenia with the war. It's something that us Israelis know very well. So I wish you and all of your families, you know, to stay healthy, especially now in these days of the pandemic. And I want to try to take you out of this war and all of this difficult time to see some cool examples. So I hope it will inspire you and give you some good feeling. I don't know. So the Metropolitan of Art Museum of Art actually collaborates with our movement for some time now. We have a Wikimedian in residence. Actually, we have two of them, and we have a data strategist that work for the Metropolitan Museum of Art from our community. And what they did is that the Met basically donated a lot of its metadata about artifacts in the museum to Wikidata. And this is what we can do when suddenly we have structure linked data. Sometimes it helps us unravel different links and connections or relationships that were always there, but we didn't know. And in this example that I did a print screen of here, this is the portrait of Madame X. This is a really well-known picture that that is in the museum. And what happened when they put it, they put the structure linked data into Wikidata, they discovered something new. And they discovered that the dress, this black dress that you see here, was inspired by a black dress that was worn by the actress Rita Hayworth in a movie called Gilda. And now this is so awesome because, you know, the curators of the museums didn't know about that. And, you know, curators are really usually people who know everything that there is to know about their artifacts, right? So they didn't know that. They found it out only when they entered it into Wikidata. So that's a small but really cool example to show the power of linked data. Another thing that I wanted to show you, and again, this is again from the Met. I didn't mention, but the Met started by donating 375,000 pictures, media files to Wikicommons. They released it under a CC0 license. And then they continue to release metadata. And this is something that exists on Wikidata. If you go to Wikidata, glam/Metropolitan Museum of Art /all objects, you'll get to this tool. And this tool basically helps us to explore this huge amount of information in a statistical way. It does that automatically using Wikidata queries. And it helps us to explore how many paintings, how many sculptures, how many drawings are there in the Metropolitan Museum of Art collection. So again, all of these statistics, all of this tool, this is a tool called Integrality. And basically it allows us to explore the different artifacts in the museum collection in a visual way. I think it's really helpful to show the impact, and also everything here is clickable. So if you click on paintings, you'll get to see a gallery. This is cool. And there's also the link to the actual thing here below. And last but not least from the Met is something really cool that they did. They created a Wikidata game called Depiction, the Depiction game. And what happens here is basically that artificial intelligence basically showcases it could be any picture from the collection. And then it will ask you in the game if you see a tree or not. And it could be a tree, it could be a horse, it could be a dress, a house, etc., etc. And all you do is play a game, right? So you would only click, yes, I see a tree. No, I'm not sure that I see. No, it's not a tree, or skip because I'm not sure. So while we play a game, behind the scenes, there are statements written into Wikidata. And what you can see on the right is a big gala event that they did, and they placed huge screens, and people from the audience, curators, people who came to that event could play that game and basically help describe all these pictures from the Metropolitan Museum's collection in Wikidata, which again will help us when we want to do queries and start asking, show me all the pictures that have a tree. Suddenly we will be able to do that and to give you something that is substantial. So that is the first example. I will say that it's not only the Met, it's also existing in the Cleveland Museum and the Smithsonian, et cetera, et cetera. Now, from the US, I want to move to the UK. That gives us a few really interesting examples as well. And the first would be from the Bodleian libraries at Oxford. And what you see here is a screenshot from a website that is, everything you see here is based on Wikidata queries. And this specific website is about astrolabes. These are navigation devices, historical navigation devices, and the Bodleian Library has a really big collection of astrolabes in it and or connected to it. So what the Wikimedian, we had a Wikimedian in residence working at the Bodleian Libraries, Dr. Martin Poulter, that some of you may know from our community, and he created this website. Now, the important thing is that you can replace astrolabes with anything at all from a museum collection, because it could basically create, it's a proof of concept, right? So you can change astrolabes with anything in the museum collection or library's collection, and you can suddenly create websites that allow people to interact with your collection in a new and exciting way. So this is a timeline, and if you click on the People's tab, then you'll see all the people who created these astrolabes, and you can see a map with all the locations, et cetera, et cetera, et cetera. But all of this is automatically generated by Wikidata, and every time a new item is added to Wikidata, any new astrolabe, it will automatically be presented on the website. So this is quite cool, I think. I'll mention that the Bodleian Library is not only one, there are many other libraries working with us, et cetera, et cetera. Now, the third example I want to give is from Edinburgh. And I think it's an important example just because this was a database that existed, this, a scholarly database at the university. So we had some experts who worked at the university and created a database about the Scottish witch hunts. It was a very dark period in the UK, in the Scottish history, in the history of the world, actually. And, people just worked for years and years to create this really high quality database. And like many, academic databases, at some point there was no money to maintain it. So it was about to be shut down. Instead, because we have a Wikimedian in residence at the University of Edinburgh, his name is Ewan McAndrew. If you've met him before, and if not, he's really cool to follow. And he's been doing lots of different things at the University of Edinburgh. And this was one example of a project that they did at the university. They basically took this academic database and transferred all the data into Wikidata. And the result was that now that it was structurally linked data, they could put it on a map. And it's a really cool map. I urge you all to click on this link and see it. You can really explore different things. And what it did, it besides the fact that it gave new life to this academic research that was almost, gone because, there was no money to basically continue to maintain it. This database is now very much live and kicking in Wikidata, and people from all over the world can now contribute to it, so they can add more layers and more details to this area. Now, think about it. Now, I'm showing you an example here of the witch hunts, but it's the same thing for a genes database, right? And GeneDB.org basically almost shut down again. And this is again another example of transforming the data into Wikidata to help it survive. And basically now GeneDB.org showcases everything they have from Wikidata. So they put it all on Wikidata. It keeps living on Wikidata. People from all over the world can contribute to it. And the website itself now presents the results from Wikidata itself. Yeah, these are my students. I'll just very briefly mention that I'm moving to Israel now, and I just wanted to mention that, you know, I've been experimenting with adding Wikidata into the academic curriculum since 2015. And in 2018, I basically opened the first course in the world to feature Wikidata. I call it from Web 2 to Web 3, from Wikipedia to Wikidata, a bit like our presentation today. And I can do lots of cool things with my students. I'll actually give an example, though not from my course, but from another course that I'm supporting. And this is a semantic web and open link data course at the Bar-Ilan University. And the thing is that the lecturer wanted the students to do some kind of project that is meaningful, right? And so we collaborated with the Israeli Antiquities Authority, and they had, you know, word pages, word documents of old buildings in Akko, which is a city at the north of Israel, close to Haifa. And we took all of that information that you see here and basically put it on Wikidata, because the Israeli authority, the Israel Antiquities Authority, didn't have the money to have it even in a database. They're working on it now, but for now they don't have it. So this is another way to take your cultural heritage and give it new life. I'm moving on to Brazil. Let's see how we are regarding time. Okay. So, Susanna, are we okay with time?
Yes, please.
Okay. So I'm continuing with really some cool examples from Brazil. And in Brazil, one of the things, because they're a very small community, and they are a country, you know, that is considered a developing country. They don't have resources. Their government doesn't have a lot of money to do a lot of important work that that other countries in the Western world take for granted. So the community is constantly looking for ways to improve access to their cultural heritage and to many things. And I want to show you a few examples from Brazil of what they did as a very small community. It's quite mind-blowing. It's quite amazing. So the first example is that they auto-generate Wikipedia articles using Wikidata. It's quite complex. I'm not going to get into exactly how they're doing this, but I'll just say that most of what you see here on the left, what they did is they took information about the elections in Brazil and they put it into Wikidata. And it helped them to basically, because, you know, for them in Portuguese, there was no information about politicians, about the elections, and the public was missing a lot of information, and they were looking for a way to give access to that information. So they put a lot of information into Wikidata, and then they created a tool that basically auto-generates the article that you see here is mostly generated by Wikidata, which is quite amazing. And I'll just mention that this is based on another tool that can help them. It's called Embable. It started with the Met, but then it was adjusted by the Brazilian community. And what it does, let me show you this, because this is quite cool. They created this tool to auto-generate simple Wikipedia articles about works of art, museums, libraries, archives, theaters, books, movies, even earthquakes and newspapers. And I just want to show you how it looks like. So let me show you that. So this is in Portuguese, this is so we're in Portuguese Wikipedia, and this is basically a template. So all they need to do is basically click on something and it will auto-generate. Let me show you how it looks like. I basically just click on a button. I clicked on a specific button, and everything you now see, this is basic information about this museum. And it also gives me a list of articles of different, artifacts that are already in other Wikimedia projects. And this was all done through the power of Wikidata. I will not save it now, but you can see how it looks like. So it will give me the info box almost immediately. It will give me some basic details, and it will give me this awesome list. And all of that was generated by Wikidata, which is quite amazing. And you can think about the impact that something like that has, especially for smaller languages and smaller communities that don't have a lot of, a lot of resources. So it's a game changer, right? And yeah, they not just for Wikipedia. This is from Wikibooks. And this whole Wikibook that you see here is basically, again, auto-generated by different information that was imported into Wikidata and was created on Wikibooks. So this Wikibooks is basically helping to explore images from the Musea Paulista that donated all of this material. Okay, moving on to another example from Brazil. You know what, I'm gonna skip it, although it's really important, but you can look at it later on, because I want to show you this. One of the issues in Brazil, again, is that the government doesn't have resources to do all sorts of things. And one of the cool things about Wikidata is that it can help you create digital objects, new digital objects that didn't exist before. In this case, you see here a map of all the monuments in Sao Paulo, and it never existed before. So the government never created something about like that. And this is a result of a university course, right? Some of you may know João Alexandre Pochensky from Brazil. He is a professor at the School of Journalism, and he gave his students a simple assignment: go and document different monuments in Sao Paulo and put all the information into Wikidata. And the result of this is that they mapped all the monuments, and it wasn't easy because some monuments moved. They basically didn't have this information available to the public, but now it exists. Now they have a map. So it's a new digital object that exists because of a work in a simple course. And they did the same thing for dams all over Brazil because they wanted to monitor dams. And so now they're able to do it simply by using Wikidata. This is the last example from Brazil that I wanted to show you. And we're getting closer to the end of my examples. And, in 2018 was a very difficult time for Brazil. They had a catastrophe happening. Their national museum got burned down. And not only that, but all the digital objects were burnt down with it. So they did a really amazing crowdsourcing project. They invited the public to donate photographs that they took at the museum. And they started to recreate the different rooms at the museum. And this is specifically from the Afro-Brazilian room at the museum. And it's using a specific tool based on Wikidata. And you can see that they were able to put in different languages, describe an artifact, put the picture in, etc. And all of that would not have been able to happen if we didn't have Wikidata. So that's quite an amazing, we call it data archaeology, this process. And last but not least, I can't, we are in an international, a global pandemic. So I just wanted to show you that Wikidata is helping us curate COVID-19 information. The table that you see here is basically Wikidata generated automatically by Wikidata. And it's a list that you can see in different languages. Maybe even Armenia has one. I haven't checked, I have to say, but this specific one comes from English Wikipedia, I believe. And you can see the different, it's not up to date, right? It's from a few months ago, but you can see the different cases, the death, the recovery rate, etc. And you can see all the references. So this is something that, again, Wikidata helps us do. It also can help us create stuff like that. This is another tool. And what it does, give it a second to upload, but it's a one page that helps you ask different queries, and it will, in a second, it will show you, this is a query for famous COVID-19 cases, so you can see it visually, and it will then ask other different questions. So in this page, you can see the query and you can see the results. And again, this is auto-generated completely, automagically through the power of Wikidata. I'm going to pause here again. Sorry, this is what I wanted to go back to my presentation. I wanted to mention that, having this technology, having Wikidata, now that you've seen some examples of the power of what we can do with it from around the world, I wanted to mention that this is a technological ecosystem, and that having open linked data available to everyone means that we can use it to create different tools. And it's been done internally and externally. And I just very, very quickly want to mention Listeria, which we're using to auto-generate different lists to help curate our work in Wikipedia. So you can go deeper to it when I release the presentation, but it's really, really great. This is how we manage, basically, Listeria is how we manage a really big Wikidata project called Sum of All Paintings, which, tries to do just that. It tries to encapsulate all the paintings in the world in Wikidata. I also wanted to mention Scholia because I know some of you come from academia, and I'll just show you how it looks like. But basically, I'm sure you all know Google Scholar, but Scholia is so cool because it allows us to see, this is just one researcher. His name is Philip Byrne, and through this tool that's called Scholia, I can explore this researcher in a very engaging new way. So this is first a list of his publication, and all I did is write down his name, and I will get, if there is a Wikipedia article, I will see an excerpt at the beginning. I can see his ORCID number. I can see a list of his publications, number of publications per year, number of pages per year, the different topics that he writes in, the authors that he, wait, let me scroll a bit down, where he published, right, which is interesting, some of his co-authors, which is again a live graph, right? So all of this page, everything that I just showed you happens automatically, simply through the power of open linked data on Wikidata. Going back and finishing up all the examples that I wanted to show you is, I have to mention Histropedia, because it's an external tool that was developed outside of Wikidata, but this is again coming to show you the power that Wikidata has, because now it's like a base that different apps could be developed on top of it. And this is a really cool example. Histropedia helps to create timelines, but in a more visual way than the basic way that I showed at the beginning. We even have now at the Prado Museum multiple timelines where you can choose. I chose here music, Prado Museum paintings, etc. But you can choose up to 5, I think, multiple timelines, and you can see different things happening at the same time, which I think is super awesome. And will soon be part of the Histropedia, the next version of Histropedia itself. There are other external tools, and there are even attempts to connect Wikidata with what is called NLP, natural language processing, which is from computer science and data science now. But this tool, basically, I spoke to the computer and I asked, who is Luke Skywalker's dad? And Platypus basically gave me an answer. And the answer was Anakin Skywalker. And you can see that the answer was based basically on Wikidata. And this is just to mention something that I didn't say at the beginning, but Wikidata today is used by different AI-based agents like Siri, like Alexa. So when you speak to your phone and you ask something, the question many times comes from Wikidata. So I hope that this, I want to conclude and just say that I hope that by now you can see how amazing and how versatile Wikidata can be. It allows us to do queries, and it allows us to visualize information and to curate work and to connect different databases and do all sorts of, ask all sorts of questions that we weren't able to ask before. But I also want to mention that it brings about questions, different questions about how we model information, how reliable is the data, how complete is the data. All of these are really important, and to me, show the mark to a new skill that we want the next generations that grow up to have, and that is data literacy, right? We want that when you interact with knowledge, with information, with data, you will be able to be a smarter consumer of information, and you will think of all of these things because you know better. Just like you look for references in Wikipedia, then you'll look for them in Wikidata as well. Visualizing information really helps us see not only what's there, but also what is not there. So we can see different gaps of knowledge, right? And then it can help us work on what is still missing. So it's accomplishing many, many things, but raising new different questions. And I'll finish with this. I'll just say that Wikidata is a step, and as some of you may have heard, the future will be connecting Wikidata to something new, a new sister project that the Board of Trustees, which I'm part of, approved last year, and it's called Abstract Wikipedia. And the idea would be to structure more and more and more parts from Wikipedia so we can translate easily between languages, and we can do some of the automated things that I showed you today in an easier way, and also overcome some of the obstacles that we have in Wikidata. But Wikidata, the existence of it, is still, what makes it all possible. So Wikidata will continue to grow as we continue to develop Wikilambda. You can all follow Wikilambda. Wikilambda is another separate lecture that you can hear, maybe even from Danny. But if you're curious, there's an interview that I did with him a few months ago. So you can go to YouTube and you can see what Wikilambda is if this is interesting to you. And this is it. This is basically, oh, sorry about that. My phone started to ring, but this is in a perfect time because I hope you enjoyed it and this exploration of Wikidata, and I want to see if there are any questions at all. So let me unshare and we can have a short discussion if you want.
Hi, my name is Anna, and I'm a data scientist and would like to know how do you see how we can use NLP in Wikidata and how we can help to develop Wikidata and Wikimedia itself. Thank you. It was a
Sorry?
By the way, I would like to thank you for the presentation because it was really great and I discovered lots of things that I didn't know about.
Awesome.
Thank you very much.
Oh, thank you so much. What an awesome question to start with. So, I'll start by saying, to answer Anna and maybe to give some context to people who might not know what data science really is and don't know what NLP is. I'll say this, I've already mentioned at the beginning of this talk that we live in a world where there's abundance of information. And I think what humanity has been trying to do for the past few years is trying to make sense of all this information. Like, how can we use it for the and when you suddenly have so much information out there, it's really overwhelming, and it's also very difficult to find what you're looking for. So humanity has been tackling this issue from different angles. And I would say Wikidata is definitely one, or rather the semantic web is the idea of structured linked data. The semantic web is one possibility to do it. Querying, right? Having structured linked data and then querying it and having answers. But humanity is also advancing from a different angle, and they intersect, right? But this different angle is what we call artificial intelligence. And sometimes it would mean that we take neural networks and train them. And by the way, many neuron trainings and artificial intelligence is trained based on Wikidata because it's free. So it's like big data, but open to everyone, right? Which is not trivial, because most of the times when we talk about big data, it would be different companies that collect information about us as users, but it will not be released. It would not be open. But now suddenly with Wikidata, we have it so we can use it to basically train artificial intelligence to be smarter and to understand more. Now, I didn't mention today Lexims at all, but the work on Lexims in Wikidata will basically at the end will replace what we know today as Wiktionary, but it will make machines smarter about language, human language. And this is trying to connect a bit more to your question, Anna, about natural language processing. And even the small tool that I showed, Ask Platypus, which is an example of that. We want to be able to basically speak to the computer or to any other machine. It could be a smartphone or whatever. We want to be able to speak in a natural language and for the machine to be basically able to understand us. It sounds very simple, but it's very, very complicated. And basically, the infrastructure that Wikidata is now creating, and Lexims and later on Wikilambda, will help to make that process easier. So I'm assuming, for instance, that in a few years from now, we will not need to know Sparkle because natural language processing will be more advanced and the computer will simply be able to understand what it is that we're asking and transform it behind the scenes into a query for us. So I see these two things, these two efforts intertwining at some point. Right now, it's mostly using Wikidata to train AI and natural language processing by extracting information. But at some point, it will get more and more collided, or more and more integrated. The better we are at AI and natural language processing, the better service we can give humanity. And I think these efforts, again, are right now at this point are done by different sections in different parts of the world. People are working on stuff, but right now it's complementing each other. other. The better it's going to be, the more information we're going to have, is going to help AI and machine learning and natural language processing become better. I'll say one more thing about that. And again, thank you for that awesome question. Wikidata today, you know what? I'll skip it. I'll skip it. I'll leave it at that. But thank you for the cool question, Anna. I hope I answered.
Yeah, thank you very much.
Great. Any other questions? Don't be shy.
Եթե էլ հարց չկա, շնորհակալություն հայտնենք ծափահարենք Շանիին. Shani, thank you so much.
You're welcome.
Great.
Thank you all. I hope it was useful. And as I promised, I will send Susanna my presentation so you can explore other things if they weren't clear. And thank you all for listening and for having me.
Thank you so much.
And I hope that next time that we meet, it's in person, without the pandemic, without, you know, some peace and quiet that we all need.
Thank you so much.
Fingers crossed to all of you and to your families, and stay safe, please.
Thank you. Same.
Thank you.
Bye-bye, everyone.
Bye.
Bye.